peroxide reacts with iodide ion to produce water and iodine. Acid must also be added for the reaction to occur. The initial reaction mixture is colorless. State what is observed during this reaction. In this reaction, acid acts as a catalyst and H plus ion represents the acid, and as a result, iodine solution is formed. State what is observed during this reaction. Look at the products. In the product side, water is formed which is colorless, but iodine is formed. Iodine, the color of the iodine in water is brown. So this would be your observation. Brown solution is formed due to the formation of iodine. The rate of this reaction is investigated by removing the sample of the reaction mixture of equal volume at time interval. Suggests why the reaction stops when the sample is added to the calcium carbonate. If you add calcium carbonate into the sample, in sample acid is present and calcium carbonate is a base. So calcium carbonate reacts with acid. As a result, reaction will stop because acid is necessary in this reaction. So answer would be calcium carbonate reacts with acid. Next question is why the calcium carbonate is powdered. If calcium carbonate is in powder form, it means it has a large surface area. If it has large surface area, then it means more number of collision in a unit time. As a result, rate of reaction will increase. So why the calcium carbonate is in powder form? To increase the rate of reaction. To increase the rate of reaction. Next question is state what is observed when a sample of the reaction mixture. In the sample of the reaction mixture, acid is present. When the sample of the reaction mixture is added to calcium carbonate is a base. When calcium carbonate react with acid, carbon dioxide gas is released. And what would be observation? Bubble formation or fizzing. Bubble formation or fizzing would be observation due to the formation of carbon dioxide. C part, after each sample is added to calcium carbonate, the content of the flask. In the content of the flask, there is water and there is iodine are titrated with sodium thiosulfate. So basically, this sodium thiosulfate, Na2S2O3, reacts with iodine solution. The sodium thiosulfate reacts with iodine produced by the reaction between hydrogen peroxide and iodide ion. The volume of aqueous sodium thiosulfide needed for each titration depends on the amount of iodine in the amount. You can see in the table, after 100 seconds, 11 cm cube of sodium thiosulfate is used. After 200 seconds, more volume of Na2S2O3 is used. After 300 seconds, more volume of Na2S2O3 is used. It means the amount of iodine is increasing, and after 400 seconds, more volume of Na2S2O3 is used to react with iodine. But at 600 seconds, you can see that no more volume of sodium thiosulfate is used. It means reaction had stopped. So in the next part, we have to draw a graph by plotting these values. So values are after 100 seconds 11 cm cube, this one, and after 200 seconds 12 cm cube, this is 12. You can see here this is 12, and after 200 seconds, and after 300 seconds 15.5, this is 300 and 15.5, this value. After 400 seconds 17.5, this is 400 and this is 17.5. After 500 seconds 18.5, and after 600 18.5, reaction stops. In the exam, you must draw a graph with the help of sharp lead pencil. Don't use pen to make a graph. Okay. Draw a circle around the anomalous point on the grid. This is the anomalous point which is far away from the curve. This is the anomalous point. Use the point to draw a curve of best fit. Use the graph to determine the volume of aqueous sodium thiosulfate needed for a sample taken at 250 seconds. After 250 seconds, this is 250. After 250 seconds, how much volume will use? Approximately 14. But if you will use the lead pencil, your answer will be more accurate. According to marking scheme, this would be 13.5, which is very close. Okay, next part. Use the graph to determine the time at which a sample is taken if 6 cm cube of aqueous sodium thiosulfate is needed. Okay, if 6 cm cube of aqueous sodium thiosulfate is needed, what time it would be? 80 seconds, and this is accurate. In the marking scheme, the answer is 80 seconds. So last part of this question, describe and explain the difference in the slope of your curve at 50 second and at 400 second. Okay, look at the graph. This is the 50 seconds. This is the 50 at this point, and 400 second mean at this point. What is the difference between these 2 points? Look at the shape of the curve. You can see that at 400, slope decreases or gradient decreases. At this point, slope decreases, and at 50 second, sharp slope. Why sharp slope at 50 seconds and why slope decreases at 400 second? The reason is rate of reaction decreases. Rate of reaction is fast at 50 second because curve is sharp, and at 400 second slope decreases, its mean rate of reaction decreases. Why rate of reaction decreases with respect to time? Because concentration decreases. Because when you start the reaction, concentration of the reactants are maximum, so more number of collision at the beginning, but after some time concentration of the reactant, amount of the reactant is used up, so lesser number of collision, rate of reaction would be slow, so there would be a lower collision with respect to time. So describe and explain the difference in the slope. Slope decreases with respect to time. Slope decreases with respect to time. Why slope decreases? It's mean rate decreases, rate of reaction decreases. Why rate of reaction decreases? Because concentration of reactants decreases. As a result, there will be lower collision rate. As a result, there would be lower collision rate. So this is the end of the question. Thank you.